Java 17 new features. JEP 406 Pattern matching for switch. Part 2. Refining patterns in switch. Experimentation with patterns in switch suggests it is common to want to refine patterns. Consider the following code that switches over a shape value. The intent of this code is to have a special case for large triangles with area over 100 and a default case for everything else, including a small triangle. However, we cannot express this directly with a single pattern. We first have to write a case label that matches all triangles and then place the test of the area of the triangle rather uncomfortably with the corresponding statement group. Then we have to use fall through to get the correct behavior when the triangle has an area less than 100. The problem here is that using a single pattern to discriminate among cases does not scale beyond a single condition. We need some way to express a refinement to a pattern. One approach might be to allow case labels to be refined. Such a refinement is called a guard in other programming languages. For example, we could introduce a new keyword where to appear at the end of a case label and be followed by a Boolean expression. However, there is a more expressive approach. Rather than extend the functionality of case labels, we can extend the language of patterns themselves. We can add a new kind of pattern called a guarded pattern, written P and B, that allows a pattern P to be refined by an arbitrary Boolean expression B. With this approach, we can revisit the test triangle code to express the special case for large triangles directly. This eliminates the use of fall through in the switch statement, which in turn means we can enjoy concise arrow style. The value of S matches the pattern triangle T and T calculate area greater 100. If first it matches the type pattern triangle T, and if so the expression T calculate area more than 100 evaluates to true. Using switch make it easy to understand and change case labels when application requirements change. For example, we might want to split triangles out of the default path. We can do that by using both a refined pattern and a non-refined pattern. We enhance switch statements and expressions in two ways. First, extend case labels to include patterns in addition to constants. And second, introduce two new kinds of patterns, guarded patterns and parenthesized patterns. Patterns in switch labels. The heart of the proposal is to introduce a new case P switch label where P is a pattern. However, the essence of a switch is unchanged. The value of the selector expression is compared to the switch labels. One of the labels is selected, and the code associated with that label is executed. The difference is now that for case labels with patterns, determined by pattern matching rather than by an equality check. For example, in the following code, the value of O matches the pattern long L, and the code associated with case long L will be executed. There are four major design issues when case labels can have patterns. 1. Enhanced type checking. 2. Completeness of switch expressions and statements. 3. Scope of pattern variable declarations. 4. Dealing with null. Enhanced type checking. Selector expression typing. Supporting patterns in switch means that we can relax the current restriction on the type of the selector expression. Currently, the type of the selector expression of a normal switch must be either an integral primitive type, the corresponding boxed form, a string, or an enum type. We extend this and require that the type of the selector expression be either an integral primitive type or any reference type. For example, in the following pattern switch, the selector expression O is matched with type patterns involving a class type, an enum type, a record type, and an array type. Every case label in the switch block must be compatible with the selector expression. For case label with a pattern known as pattern label, we use the existing notation of compatibility of an expression with pattern. Dominance of pattern labels. It is possible for the selector expression to match multiple labels in a switch block. Consider this problematic example. The first pattern label case, char sequence CS, dominates the second pattern label case string S because every value that matches the pattern string S also matches the pattern char sequence CS, but not vice versa. This is because the type of the second pattern string is a subtype of the type of the first pattern, char sequence. A pattern label of the form case P, where P is a total pattern for the type of the selector expression, dominates a pattern label of the form case P, where P is a total pattern for the type of the selector expression, dominates a label case null. This is because a total pattern matches all values, including null. A pattern label of the form case P dominates a pattern label of the form case P and, where the pattern is a guarded version of the original pattern. For example, the pattern label case string S dominates the pattern label case string S and S length greater than 0. Since every value that matches the guarded pattern string S and S length greater than 0 also matches the pattern string S. The compiler checks all pattern labels. It is a compile time error if a pattern label in a switch block is dominated by an earlier pattern label in that switch block. This dominance requirement ensures that if a switch block contains only type pattern case labels, these will appear in subtype order. The notion of dominance is analogous to condition on the catch clauses of a try statement, where it is an error if a catch clause that catches an exception class E is preceded by a catch clause that can catch E or superclass of E. Logically, the preceding catch clause dominates the subsequent catch clause. It is also a compile time error if a switch block has more than one match all switch label. The two match all labels are default and total type patterns.